you're designing any structures, we have to design with considering of two things here. One, your strength, and other, your serviceability. Suppose that a building fails in serviceability. So first we have to understand that what the serviceability is, under what all things serviceability will come. Okay. So first thing which we have to understand it, at what condition the serviceability and what all the consideration is under the serviceability comes. So your cracking, one of the cracking comes under the serviceability criteria. Okay. This is the major thing which I will talk about cracking. Okay. So if suppose that any structure is that, and if a structure has cracked, okay. So do you think that structure is going to fail with the crack? It will be only cracking, but a structure is not going to fail it. So we can say that such structure is it is servicing it. It is serviceable, but it is not going to fail it. That comes under the limit state of serviceability. Suppose cracking is comes and all shrinkage and all it comes it, then it does not mean that a structure is going to fail completely. Okay, so that always we have to keep it in our mind. The serviceability criteria. We have drift also. Okay, we have grow. If you talk about foundation, there will be ground bearing capacity that we have. Okay, so these all criteria. I will talk about drift. Okay, it is we generally call it ground bearing pressure. Okay, then there will be might you can talk about shrinkage here. Okay, so and also if you talk about the controller deflection out of cracking, see you can see that cracking a structure will not fall. If drift, a structure is not going to fall. Gross bearing pressure, a structure is not going to fall. Shrinkage, a structure is not going to fall. Okay, so a structure will become a serviceable, but it will not look good if some crack is there. So structure is not going to see very beautiful there. Okay, so if you see our design code at the limit state of design, we have to satisfy two things here: limit state of serviceability and limit state of strength. The two things we have to satisfy it. Okay, so this limit state, sorry, this controller deflection, which I was talking about, it comes under the limit state of serviceability, and we have to satisfy some conditions. So if you see the load combination is which load combination we have to check this. So load combination we have to take it for this check is dead load plus live load, and you know that in the limit state of serviceability we do not give any factor load there. So there will be not any factor load. Suppose if I have to design these beams and columns, then there we use a factor that is 1.5, or some code it is 1.4 also. Okay, but if you talk about limit state of serviceability and the load combination which we are going to use is generally we take it as a unfactored. Unfactored means completely it is not going to be factored. Simple dead plus live. This load combination we have to consider it. Okay. So limit control or deflection means that we have to control deflection in our structure. That we have to keep it in our mind. Okay. So what all the criteria the code has given? If you see the IS 456, see the IS 456, we have some limit of deflection. Means that our deflection should not exceed with some value. Okay. In IS 456, you will get the clause. So if you see the first one of the important points here, that your structure deflection should not exceed a span by 350. Okay, and also which span? The span is shorter span. I will write it shorter span. Okay, or 20 mm, whichever is less. Okay, so your limit of deflection means that your deflection should not exceed by this value. Okay, that we have to keep it in our mind. Second thing which we have to keep it in our mind, what our creep coefficient. Okay, So what is creep and all? Just for understanding of creep, just understand that how the creep is going to happen. Suppose that there is one slab, okay, and in slab you have applied some loads here, okay, and you cut the slab, you cut the section of the slab, and you see the deflection, okay. So when the load is applied, what you will get? You will get some deflection here. Okay. We generally call this deflection as a elastic. This is the straight deflection I'm counting from here. So this is the deflection which I'm talking about. So we generally call it as a elastic deformation. Okay. Elastic means that when you remove your load, again it will be back to original place, means that is elastic. Elastic generally here refers about that when you apply any load to it, it generally deform it. Okay. So what deformation it is, just software will give you that 8 mm, 5 mm, 4 mm of deformation, maybe it will give you. Okay. And but you know that we are not interested in this deflection because you know that the material which we are going to use, it is a time dependent property of material. Time dependent means according to type it is going to vary, it is going to it is vary. Okay. So if you want to introduce a time dependent property in our material, then we have to do the creep analysis, that I will take another class of the creep analysis just after this class. There will be creep analysis class. Okay. So first in today class we will just understand about the creep. What is the creep? Is that creep is what? It is a constant deformation, we can say that constant, and due to which, due to the constant load also. Suppose that there may be a tiles load, okay, there may be any loads which is a constant at that place, and it will be remain along the whole life of the structure. Okay. And also the deflection which is going to happen, it is going to happen like a constant one, little is going to increase it. Okay, not constant, it is going to increase gradually, that we can say that. So that is your creep. Okay. So creep generally it is more than this elastic. This will be creep deflection.
Okay.
Okay. So you know that if you're doing only a simple analysis, in that case, you will get only the elastic deformation. Okay. But if you perform the creep analysis, then you will get a creep deflection also. That's clear to everyone. But suppose that I have any slab, okay, and I don't want to do any creep analysis and all, then you can take the creep coefficient. There are 2.5. There is code, sorry, not code, but by experience as structural engineer, you can take 2.5 or 3. This is a creep coefficient. Okay. So just I will look, I will just show you where it is written and where the code says and all. Just we'll see it. So let me open my code. Everyone, please watch this close. Creep of concrete. Okay. So it is carefully written here that at loading 7 days, your creep coefficient is 2.2. 28 days creep coefficient is 1.6, and 1 year creep coefficient is 1.1. So you know that you're not going to design your structure for 1 year. You're going to design structure for more than 30 years and 40 years. So in that case, what creep coefficient you will consider? Okay, so see, you can see that in the absence of experimental data and detailed information on the effect of variable unlimited creep strengths, instead from the following values of the creep coefficient. Okay, it is written that suppose that you do not have any absence of experimental data, you don't have any experimental data and all, and detailed information. In that case, you can take this creep coefficient, calculate that deflection, that last one I talked about. So this is your elastic one, and this is your creep one. So this deflection which I'm talking about, Okay, you can have some experimental data, but it is not possible to have experimental data. I know that. See how you can make experimental data, how you can make it. Suppose any span is that you can apply the load for 30 years, you will wait for 30 years to see then what is the creep there. It's not practically it's possible. Okay. The software, sorry, the code has given you something values like 7 days, what creep coefficient you will use, for 28 days, what creep coefficient you will use, for 1 year, what creep coefficient you will use. The code has given you some values. But what about 30 years? No, code has not given about 30 years and all. Okay, so if you refer any other codes like Canadian codes and all, you in that code you will find the creep coefficient, and also if you're talking about highways and all, in that we have IRC codes. Okay, in that code you will find the creep coefficient, but not in IS Proper 6 code you will find a creep coefficient for 30 years. Okay, software the code has clearly defined it that we do not have this deflection, including the effect of temperature creep and shrinkage occurring after the erection of partition, and application of finishes should not exceed normally span by 350. What the code says that, okay, the deflection I'm talking about, which we have to consider what effect, temperature effect, your creep also, and also your shrinkage effect. So we have to consider the effect of temperature, effect of creep, and effect of shrinkage. Okay, occurring after the erection, not see we have before erection and after erection also, but we generally you know that only it will be considered after erection only. Okay, so after erection of partitions and applications of finishes means tiles and all, so not normally exceed a span by 3, sorry, a span by 350 or 20 mm, whichever it is. Okay, so these important points which has the software, sorry, the code has given you that your deflection of your structure with consideration of temperature, with consideration of creep, with consideration of shrinkage, should not exceed a span by 350 or 20 mm, whichever is less. Okay. So what we are going to see, just for example, we will open the software and just we will see that, okay, how we can implement this control of deflection in our software. Just I will try to analyze this file. Okay, so if you want to analyze your file within very fast process, you can have a SAP file options here. You will get a multi-thread solver here. Okay, and use this multi-thread solver to analyze your file very speed. Okay, but if you have any some basics that some laptop do not support the multi-thread, because see if you talk about a generation of a laptop, suppose it is 5th i5 and having 9th generation, 10th generation, they depend upon threads. There is a multi-threads course. Okay, so suppose that your laptop have 4 cores, 6 core, 8 cores and all, so on basis of that course the multi-thread will work it. Okay, you can see that how fast, how quickly my building is analyzed. I think it not had not taken more than 30 seconds also, if I'm right. Okay, so just see it. So you know that this is our we can say this is not a standard, and we can say that graphics we are using direct statistics graphics. So you can switch it to a standard graphic from options. There you will get a graphic modes. You can have a standard graphics here. Okay, and one more thing, no ETABS has come with a 19 version. Okay, so just any days I will also explain you what enhancement has been done by ETABS in the 18 to 19 version. That also we have to study some of the enhancement the software has given you. Okay, so you can see that I'm using a 19 version, not 18 version. You can see it clearly.
Yeah. Yeah. Yes.
So how we can see that you have to go, you see, you come with the plan here. Okay, in the plan, you will find this. You have to first define your load combination. Go to define option, you will find a load combination here. We'll add a new load combination. There you will write it date plus live, and you can use a word serviceability like ASER. Okay, so you know that this is unfactored, so we have to add dead and live only. Just keep it okay and okay. So this step is clear. Defining your load combination, it's very simple. You have to go define option. There you will find load combination. Okay, you can add new load combination here and you choose your load cases and you add it. After that, you have to go for show deform shapes. Okay, so can you use as word? You can use icon show deform shapes here, and in that there is a combo. Okay, you select this and you have a draw contours on objects. Okay, you click and you will get a displacement user direction. You apply it. Okay. So what is the contours here? Just I will explain you. If you see the short deform shape, you will have a contours. So contours is nothing. It's simple. Just in a small definition, you can understand that. Suppose that I have to have some range like minus 0.1 to I have a range of 0.6. So I will give this as a red color. Okay. Another, suppose that I have deflection of -2 to -10. Okay, so I will give it as a black color. Okay, -5 to -20. I will give it as a suppose that I am give it as a green color. Okay, so it is like a contour. Is like a you see the pH scale. If you see the pH scale, according to the pH value, you get color. Okay, so in the software also, what happened here? The software has given you some color indication. Okay, like a red one. Okay, and also if you watch carefully in the below, if you see that here, this given you that about okay how you can select this. Suppose that if I want to interested in deflection of -18, so I will just see that this color only. So what is the range is -9.5 to 18. So if it is color is this, so means that this is the range in this deflection. You can see that. Okay, suppose that I am interested in deflection more than 21. Okay, so you will get this color only. So you can see that. So if you go above like in terrace and all, you will find this color of this shape also. You can go to terrace. Okay, so yeah, so terrace you found this color. Okay, so this color is what is matching with this color is matching with this. So if you see the deflection, it will be nearby 21. It's really more than 21 here. So you can see that it is 22. UZ value you have to see. Okay, see everyone UZ value how much it is. So it was a 22 around. So why we are seeing UZ? Because of deflection only. We are interested in vertical deflection. Yeah.
Okay. So for which this -21 or 22 value is coming. So what is the permissible value? How we check permissible
Oh,
value from code?
okay.
It is
That I'm telling you. Don't worry. Okay. That is
okay.
a limit of state of. I told you then limit state of. We have some controller deflection limit. Okay. So first you understand
Okay.
that how we are checking this. Okay.
Okay.
So yeah, checking is clear that it's very simple. You select your load combination, show deform shape. You show your deform shape in the vertical direction. Okay, and now we have to check your that see in the left side you will find value like -22 and all. So this is your maximum value. You will get it -22.38. This is the maximum value the software will give you the left side. Okay, so how we can see that
It's
where this
minimum.
not minimum. It is written minimum, but you know that this is the minus value it is. Okay, so
Okay. Okay,
deflection
sir.
will be
Got it.
always in the minus only. So it is written minimum, but this is the maximum. You can see that. Because you know that in maximum you will get a positive value. So if you can see that we have got a maximum deflection, and also software is given the coordinate like minus 0.4, 4.62. Okay, I will just show you where it is. Okay, see this value minus 22.138 at 5.4, 4.62 and 27. So what this all value is? This value is a coordinates. So you start with your last one. Last one is 27, means it is on 27-meter height. Okay, it's like coordinate like x, y, z. So you know that it is x is 5.41, y is 4.62, and z is 27. So z is what? It is a vertical. So if it is a vertical, so we are on right now 27 only. That is on terrace only.
Okay.
Okay. So you know that, see, and also one more thing we have to see that, see, I explained you about the coordinate system. So if you see the coordinates, okay, you can see that this is the value which is already shown by the color. See, you can see that value. It is minus 22.138. If you see here also, it will 21. It is greater than 21. Okay. So just I will explain you how you can see the deflect. Sorry, you can make that this value should not exceed by that value. I will check you for this slab. Okay. So right now remember this value. It is at minus 22.138. Just again once more. 22 point. You can take it to, you can round it with 22 only. Okay. Come back to the our whiteboard here. So this is the span by, okay. So yes, come to the basics. That is, I talk you about that creep and all. Okay. So yeah. So span by 350 is your limit. Okay. So we have to see that I told you this shorter span. So suppose this is the span. So we are interested in the shorter span. Okay. So just check it on the software where this deflection has been happened. What is the shorter span of it? So how will check it? So you know that this deflection is here. You can make undeform here. Okay, so this deflection we're interested, or I think it is here, no? Just once you can check it more. You can take this value minus 22, minus 21, this value. So check it here. Okay. So it is just at joint, this value which you're getting. Okay. So you know that you have to take shorter span. So you just take the shorter span. So shorter span, if you take it, so you have to consider this as a full span only. So it is a full span. Okay. So you know the shorter span will be this only. Okay, this will not as a shorter span act. This will not as a it will act as shorter span. This will act as a shorter span. Okay. So how I can count the shorter span? Just right click. You will find, go to geometry. It is 3.72. So 3.72. Remember this value. Come back to the software. You write it. This value, that is 3.72. This shorter span. I will erase the. I will just erase this data. Sorry, erase this graph because it's no need. Just remember this value, 3.72. So our shorter span, it is 3.72. Okay. So what I told you, we have to divide by 350. So divide by 350. Okay. So how much you will get it? Anyone idea? Calculating, when you open the calculator and you can see that how much you're getting. And also if it is
10.62.
10.62,
62.
you will get it. 10.62 mm. Okay. So we have to compare this value with 20 mm. Whichever is less, 20 is less or 10 is less. Of course, 10 is less. Okay. Then we have to consider this value. Suppose that in any case, just I'm taking an example. Suppose that a span is 20 meter and it is a 350. Now how much value? Maybe its value increased by 26 or 27. You can assume it that its value is coming around 27. Okay. So this 27 is greater than 20. Yes. So I will take it 20 as a limit, not 27 as a limit. Okay, Janice and Arbaz and Nanu also. Why this
Yes.
given 20 or 20,
Yes.
whichever is less. So always we have to keep it in our then 20 is our only limit, because some value, if you know is a longer span, if some value will be of longer span, definitely it's your limit will also increase, that it is going to have like 30 and 40. But you know that if it is deflecting 30 and 40 mm, so you how much reinforcement will be required to clear the deflection, that also is one of the important thing which you have to consider. Okay, so you got 30 points, that is a limit. Okay, so just I will ask you some one of the basics question. Okay, but it's very very basics. Okay, it's also one of the tricky question also. We can give it as a trick. I will give not a basics. I will give as a trick question. Okay, suppose that I am seeing this deflection. Okay, just I am seeing this deflection. Okay, and what see what the software has shown me that 22.138. Okay, so whether this software has given this value, it is right or wrong. Mean to say that the software has calculated on basis of part how much deflection has been happened. How the software has count this value? You know that it is deflecting 22 mm, means that there should be some reference from where it is counting, that from where it is going to deflect, from where it is going to deflect 22 mm. Okay, so just give me that from where. Two options are there. One is from column and other is from floors. Floors means that where you have defined. Suppose right now I am in 27th floor. So software is calculating this 22 mm from 27th floor, or it is calculating from the columns how much it is deflecting. What my question?
I think floor.
Anu, you?
Yeah, even I think from the slab it is showing that value.
Yeah, it is flowing the slime, but from where it is counting that it is deflecting. You got, I think you're not got my
Yeah,
point. Okay, it
yeah,
is
I
deflecting, but from where it is deflecting? There should be some reference on it that you have to count it, that okay, it is deflecting 20 m from this axis, from this axis. So it is software is showing from 27th floor, okay, 27 meter of the floor, or it is counting from column.
no from the floor.
That from same answer like Janice has given. Arvaz, you, what do you think?
It's from the floor only.
Floor, yes, all right. It is showing from floors how much it is deflecting. But if you see the real deflection, okay, so do you think that we have to count it from floor, or we have to count it from the column how much it is deflecting? Because you know that along with deflection, your column is will also deflect it. That is known as axial shortening of column. Okay, so column will also deflect it, no, along with your this deflection. So we have to consider that deflection also along with deflection. Okay, so how we'll consider? Just go to the nearby columns. Suppose that just undeform it and see that, see I'm taking this here. You can take one of the this column only, and how much it is deflecting. Just go to show deform shapes. You take a user value. Okay, so I think this, yeah, and I think you can take this value also, both nearby it will be same only. Just once check it that this only that is right. You have to undeform it and check it that yes, we are taking the right value. Again, so deform shapes, right, and close. Okay, so how much you can take a right click and see it. How much it is? It is minus 13.98. Okay. And what is the virtual deflection we are getting? 22. Okay. So you have to minus two things here. So just remember this value 13 and 22. How much you will get it? Real deflection. Your virtual deflection was how much? It was 22, right? So I can write it virtual deflection was 22. And you go to axial shortening of column. Axial shortening of column. How much it is? It is 13 point something. Okay, I make the round and given this value. So the real deflection will give me how much it will be?
9.
9. 9 mm is the real deflection, not 22 mm. It is a virtually. Virtual means that deflection, why you need to count it? Because we are interested from column how much it is reflecting. Okay. So we have gone the virtual. We have the 9 real deflection. I also know that this is reflection, which is the elastic deformation. And now we are interested in what? We are interested in the creep. So you know that creep we have a value of 1 year only. So I will just make it for 1 year. You have to multiply 9 with 1.1. You will get a 9.1 as a creep deflection there. But if I'm not interested in 1 year, I'm interested in 30 year and 40 year. Then you have to multiply by 2.5 and 9. So result will be how much it is? It will be near about
22.5.
22.5. So this 22.5 we have to compare with which value? That this value 10.62, that is our limit. Okay. So if our structure is within the limit as per the code, no, it's not our within the limit. Carefully, clearly we can see that.
Yes.
You can see that this is the value 10.62 and we have value of 22.5. So definitely 22.5 is greater than 0. But you know that this 2.5 we have used this creep coefficient. It is not exact. We can say that. For better analyzing, we have to do the creep analysis. Better result. Okay, so see 2.5 how this value came upon. This also code has not given you nothing. No one has given. Just it is like assumption value. You take it like I told you in the time period 0.9 multiply by the numbers of structural floors there. Like this only. It is just taken this value 2.5. Okay, but what happened for proper doing the for proper of deflection, we have to perform the non-linear creep analysis that we will see in the next class. What we have to do? Non, I will write it on here. Non-linear creep analysis. Okay. So this we will perform in the next lecture, and there we will see how what are the consideration, what are the material time dependent property, and all we have to introduce in the software. Okay. Everyone clear? This controller
Yes.
deflection, I'm only the result of whether my deflection is increasing or not. Just he will tell you like this only. Okay, so this type of analysis is very, very important. See, every structural firm is you can say that performing this type of analysis because he has to make the report and give to the client. You have to keep it for further investigation and all. Okay, so everyone is need to perform this analysis.